This video is on time travel. Yes, time travel is possible. Being done in the future, you guys are going to come up with it. And possibly one of the reasons is what I'm going to give you to you now. Let's start out a little preface here. We're going to start out by introducing some concepts. Okay. Recently I saw you guys, you humans, have come up with the idea of you have mice that glow in the dark because you took genes and you took them from I believe glowing jellyfish, and you introduced those genes, in these proteins, I guess, or genes, something like that, into the fetuses of mice, so that when they grew up and everything like that, were born and were growing up, they glow in the dark. Well, that's called cross-species gene pollination. It's going to be very common in the future. And if you take that and extend this idea of taking genes from one species and incorporating it into another, well, we are a species. Humans are. And, or at least you humans, I should say, are a species. And you have many other species on your planet. And here's the thing, one of those species is a certain type of lizard, I forget what it's called, but that species has some type of, let's see, it had what was called an enzyme. Enzyme. That when this species ends up with a freeze comes along, cold weather comes along, and it freezes this lizard. Totally like an ice cube. You're talking about a lizard sickle. Okay? The enzyme in that lizard, as it's thawing out, the lizard just comes right back to life. You incorporate that using cross-species gene pollination into another species, and that species will have the same capability. Now, I don't know if there are other things that would go work with this enzyme. I'm sure the research and technology the researchers and scientists will experiment with that and see if they get it right. When I start with mice, again, you'll have not only glowing mice, but glowing mice that you can throw in your freezer and then pull them out later and play with them. You feed them less often, what can I say? You got these mice, you can thaw them out, play with them. Feed them just a little bit, put them back in the freezer for a week or so later, and okay, you're ready to feed them again. You pull them out, thaw them out. Okay, enough of that. Anyway, time travel. That's what makes time travel possible. You isolate that enzyme and whatever else, I don't know if there's a gene that works with this to give the lizard the ability to be able to be frozen and then come right back. But what happens when you freeze something? All metabolism and everything stops. All cellular degradation, all that kind of stuff. Cellular decay, whatever the terms are. And then a human being, now this is only possible for right now, what you guys will ever see, in one direction. And that is into the future. You can't go back in the past using this type of time travel, this type of cross-species gene pollination type of remedy for traveling through time. So basically, by being able to be frozen, say the heat becomes viable later on, which actually it will, and people can be frozen because they've isolated this enzyme and incorporated it into the human genome, and you can be frozen and then come back to life later. Well, the only thing then is just how much time. How much time can you do this for? How long? That's the only question that's left. So there will be experiments, and they'll start with mice, of course. But then you have time travel becoming a possibility, at least traveling into the future, if you want to see what the future is going to be like. I don't know if you'll be able to come up with anything like a retro virus or retro cross-species gene pollination type thing, but your kids might be able to. And so human beings in the future will be able to do that. You can actually have yourself frozen, and then it becomes possible. Because if one species can do it, hey, why can't another, right? So there you go.